Ladies and gentlemen, not every achievement, struggle, or thought needs to be broadcasted. Keep your goals close to your heart until they blossom into reality. Finally, remember that you have the power to chase what you need. Today, I want to teach you something that is an incredibly important. I would like to share every detail to take the steps for your solution. And now let's begin with today's topic, which is on mathematical induction, and this is related to MFCS DMS DMGT and Intermediate 1A. So now in this video, using mathematical induction, we are going to solve a plus d plus a plus 2d plus and so on up to n terms, which is equal to n by 2 terms of 2a plus n minus 1 into d, where n belongs to a natural number. First of all, this is an important question. So please remember that here the nth term is not given. We have to find out the nth term and then we have to process with our mathematical induction. See here, in the solution, first of all, we have to find the nth step. So here the nth step is not given, and therefore the series a plus d, a plus 2d plus and so on, which are in arithmetic progression. And therefore the nth term will be a plus n minus 1 into d. Remember that. So this is a plus n minus 1 into d. So in place of nth term, I am going to substitute a plus n minus 1 into d. So which is equal to n by 2 times of 2a plus n minus 1 into d. So in this nth term, so I have substituted a plus n minus 1 into d. So here, this will be the statement. Let S of n be the statement. Now, according to our mathematical induction, so first we have to keep n is equal to 1 in the statement. So here, this is LHS part and this is RHS part. In the LHS part, we have A. And in the RHS part, this is n by 2 times of 2a plus n minus 1 into d. In place of n, after substituting n is equal to 1, so this will get cancelled, and 2a by 2, which is equal to a. So LHS value is a and RHS value is also a, and therefore both the values are same. So LHS is equal to RHS and S of 1 is true. The statement when keeping n is equal to 1 is true. And the next step, according to our mathematical induction, what we have to take is, so we have to assume S of k is true. So we have to assume that for n is equal to k, the statement is true. So this is the statement. So in place of n, so we have to keep k. And in place of n, we have to keep k. Here n, we have kept n is equal to k. And this is equation number 1. So after proving S is equal to 1, so we have to assume n of k is true. And this will be the equation 1. In the third step, so now we have to show that in the third step, S of k plus 1 is true. So which means that. So what is our nth term here? So nth term, we found that a plus n minus 1 into d. And this is the nth term. And what will be the k plus 1th term? So in place of n, we have to substitute k plus 1. So after cancelling, it is a plus kd. Now this k plus 1th term should be added on both sides of the equation 1. So what is equation 1? So equation 1 is nothing but the equation after substituting n is equal to k. We assumed this as equation 1 on both sides LHS and RHS. We are going to add this k plus 1th term. So now this is equation 1 and now we have added a plus kd on both sides of the equation. So here this is LHS part and this is RHS part. Now in the RHS part I am going to solve. See here in the equation. So this is LHS and this is RHS. Now I am going to check what happens in RHS. So as there is 2 here and there is no 2 here, so I am taking 2 as LCM. Clear? This will be k into this is 2a plus this value is k minus 1 into d plus. So it is 2 times of this is a plus this value is a plus kd. Clear? And now if I multiply, this will be 2ak, and if I multiply inside, this will be k minus 1 into kd. If I send 2 inside, this will be 2a and this is going to become 2 into k into d by this value is 2. As you can see here very clear, there is kd and there is kd here. And if you observe this one, there is 2a and there is 2a here. Now I am taking 2a common And see what happens here. If I take 2a common, this will be k plus 1. So in these two terms, if I take 2a common, this will be k plus 1. So if I take kd common, this will be k minus 1 plus 2 into kd by this value is 2. See here, 2 minus 1 is again 1. So this will be 2a into this is k plus 1, and this value is 2 minus 1. So this is k plus 1 into the value here is kd by 2. So if you observe this one, so k plus 1 is common here. So after taking k plus 1 here, so what remains after taking k plus 1 common? What remains here? This is 2a plus this value is kd. Clear? This value is kd by this is 2. And now this can be written as k plus 1 into, so if you see, this is 2a terms of this k plus 1. I am going to write as k can be written as k plus 1 minus 1 into d, as I am adding and subtracting. So 1 here, you know why? So here I'm just showing you the nth term here. So here in the RHS part, what is there? So this is n by 2 times of 2a plus n minus 1 into d. So this is the RHS part. So what is the RHS part here? So n by 2 times of 2a plus n minus 1 into d is the RHS part from the statement. From the statement, n by 2 times of 2a plus n minus 1 into d. So here after solving, what we got? So n is replaced by k plus 1. So in place of n, this is k plus 1. Again this is 2a. In place of 1, k plus 1. So this is minus 1 into d by 2. And this is nothing but, so this is nothing but s of k plus 1 is true, as we got the RHS part after replacing n is equal to k plus 1. This is what we have to show, and therefore s of k plus 1 is true. And therefore our statement here, so what is our statement here? That is a plus, so this one a plus d plus, so this is a plus 2d plus and so on. This value is, last thing is a plus n minus 1 up to n terms, that is a plus n minus 1 into d terms, which is equal to, so this value is n by 2 times of 2a plus n minus 1 into d is true for every natural number, as it is true for n is equal to 1, 2, 3, 7 and so on, k and so on, k plus 1. Therefore it is true for every natural number. See, let's begin. Back to the beginning. So this is the question given. So we have to find out the nth term. In order to find out the nth term, as these series are in AP, the nth term for the series is a plus n minus 1 into d. So after replacing the nth term as a plus n minus 1 into d, we have to check with n is equal to 1. So here the LHS part is 1, and RHS after keeping n is equal to 1. So this is also a, and therefore LHS is equal to RHS. And next thing is we have to assume that it is true for n is equal to k. So in place of n, after keeping n is equal to k, this will be equation 1. In the third step, we have to prove that it is true for n is equal to k plus 1. So here the nth term is nothing but a plus n minus 1 into d after keeping k plus 1th term. So in place of n as k plus 1th term, that is a plus kd. So this a plus kd should be added to both sides of the equation 1, as equation 1 we got using n is equal to k. So after adding, so this will be the RHS part, and after solving the RHS part, so 2 was taken as LCM, and therefore 2a is taken common, and here kd is taken common. So this is k plus 1, so k plus 1 is taken common. This is 2a plus kd, and for my simplification I wrote this as k plus 1 minus 1, as the RHS part of the given statement is this one. So this is replaced, n is replaced by k plus 1, and therefore s of k plus 1 is true, and therefore the given statement is true according to the mathematical induction. As this is most important, please go through the video if you doesn't understand for one more time, and please pass it on to your friends. If you really like this video, you know what to do. Please subscribe to this channel, raise your thumb, and have a look at my next video. That is also very important. And please avail the playlist. So many videos are uploaded for your preparation, and it will be damn easy for your preparation. And therefore I finally say that please support this channel by your subscription. Thank you so much.